Welcome to PRISCI-ANTO Educational Academy. In this session, I am going to explain you the 16 mark question in Fourier transform. It's a very important question. Let us see the question. Show that the Fourier transform of f of x is equal to two values. One is a square minus x square, comma modulus x less than a. Another value is 0, otherwise is 2 into root of 2 pi pi sin SA minus SA cos SA whole divided by S cube. Hence, show that subdivision 1 is integral over the limit 0 to infinity sin t minus t cos t divided by t cube into dt, which is equal to pi by 4, pi divided by 4. Second subdivision is integral over the limit 0 to infinity sin t minus t cos t divided by t cube whole square into dt, which is equal to pi divided by 15 using Parseval's identity. In the previous video, I explained you the Fourier transform formula and the inverse Fourier transform formula, Parseval's identity formulas. So now answer is Fourier transform is capital F of small f of x is equal to capital F of s is equal to 1 divided by root 2 pi. Integral over the limit minus infinity to plus infinity. F of x e power isx dx. So, given f of x is equal to a square minus x square, that is given, comma modulus x less than a. Modulus x less than a means minus a2 plus a. X, the limit of x is minus a2 plus a. Another value is 0. The limit is otherwise. Because f of x is 0, so we are not going to use the limit. So capital F of small f of x is equal to 1 divided by root 2 pi integral over the limit minus a2 plus a square minus x square into e power isx dx. So 1 divided by root 2 pi integral over the limit minus a2 plus a square minus x square e power isx can be written as cos sx plus I sin sx into dx. So you can, in the next step, you can separate into the two integrals. 1 divided by root 2 pi integral over the limit minus a2 plus a square minus x square cos sx dx plus I divided by root 2 pi integral over the limit minus a2 plus a square minus x square sin sx dx. So the second integral is a square minus x square is even function. Sin xx is sx is odd function. So the product of even function and the odd function is odd function. Right? So even function, odd function is odd function. So here the product of even function and even function is even function. So 1 divided by root 2 pi integral over minus a2 plus a square minus x square cos sx dx. Second integral is 0. So here minus a2 integral over the limit minus a2 plus a can be written as 2 into integral over the limit 0 to a. So therefore, in the next step I have written 2 divided by root 2 pi integral over the limit 0 to a square minus x square cos sx dx. So you have to remember integral over the limit minus a2 plus a square minus x square cos sx dx is an even function. Integral over the limit minus a2 plus a square minus x square sin sx dx is odd function. So therefore, odd function value is 0. So now we are going to find the value for this one. So 2 divided by root 2 pi, integral over the limit 0 to a, right? A square minus x square cos sx dx. That can be written as 2 divided by root 2. So in the numerator you can write 2 can be written as root 2 into root 2 divided by root 2 into root pi. So numerator as well as denominator root 2. So therefore 2 divided by, right, root 2 divided by root pi. 2 divided by root 2 pi can be written as root of 2 pi pi. Integral over the limit 0 to a square minus x square cos sx dx, which is equal to root of 2 pi pi integral over the limit 0 to a square minus x square cos sx dx. This can be solved using the Bernoulli's formula. So integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 minus etc. So u is equal to a square minus x square, v is equal to cos sx. So u dash is equal to one time differentiation a square minus x square minus 2x, u double dash minus 2, u triple dash 0. So here v is equal to cos sx. v1 is equal to cos sx, you have to integrate sin sx by s. v2 is equal to sin sx by s, you have to integrate again minus cos sx by s square. v3 is equal to minus sin sx by s cube. So u v1 minus u dash v2 plus u double dash v3. So root of 2 pi pi a square minus x square sin sx by s minus u dash minus 2x v2 minus cos sx by s square plus u double dash minus 2 v3 minus sin sx by s cube. The limit is 0 to a. So in the next step you can write as root of 2 pi pi a square minus x square sin sx by s minus 2x cos sx by s square plus 2 sin sx by s cube. The limit is 0 to a. First you have to apply for x a upper limit. So root of 2 pi pi a square minus a square sin sa divided by s minus 2a cos sa divided by s square plus 2 sin sa divided by s cube. Next you have to apply the lower limit 0. 0 means a square minus 0 sin 0 divided by s. Sin 0 is 0 minus 2 into 0 2x. So 2 into 0 cos 0, 2 into 0 0, 0 into cos 0 0 plus last term third term 2 sin 0. When you apply the lower limit every term will become 0. So therefore a square minus a square first step cancel. So 2 into root of 2 pi pi sin sa divided by s cube minus a cos sa divided by s square. S cube, if you are taking LCM, capital F of small f of x is equal to f of s is equal to 2 into root of 2 pi pi sin sa minus sa cos sa divided by s cube. So this is given in the problem. So we have derived. Next, the inverse Fourier transform is small f of x is equal to 1 divided by root 2 pi integral over the limit minus infinity to plus infinity. F of x is equal into e power minus isx into ds. So small f of x is equal to 1 divided by root 2 pi integral over the limit minus infinity to plus infinity. F of capital F of small f of x is just now we have got the result. So 2 root of 2 pi pi sin sa minus sa cos sa divided by s cube into e power minus isx into ds. So f of x is given in the problem a square minus x square, which is equal to 1 divided by root 2 pi integral over the limit minus infinity to plus infinity 2 into root of 2 pi pi sin sa minus sa cos sa divided by s cube. E power minus isx can be written as cos sx minus I sin sx into ds. So a square minus x square is equal to 2 divided by pi, because 2 into root 2 into root 2 pi divided by root 2 pi. So root 2 cancel, root pi will become pi. So a square minus x square is equal to 2 divided by pi. This minus infinity to plus infinity can be written as 2 into 0 to infinity. So that's why I have written here 2 divided by pi, 2 into integral over the limit 0 to infinity sin SA minus SA cos SA divided by S cube cos Sx ds. Here the odd function, which is the odd function sin SA minus SA cos SA, there are two integrals. We can separate into two integrals. First integral is cos Sx. Second integral is minus I sin Sx. So I sin Sx is odd function, so value is 0. So therefore, by taking a is equal to 1, x is equal to 0. So a is equal to 1, x is equal to 0 means by taking s equal to s is equal to t. So ds is equal to dt. Instead of a, you have to apply 1, x equal to 0, s equal to t. So therefore, 1 minus 0 is equal to 4 divided by pi, integral over the limit 0 to infinity, sin t minus t cos t divided by t cube, cos 0 into dt. So 1 is equal to 4 pi pi. This 4 pi pi, if it goes to left hand side, it will become as pi divided by 4, which is equal to integral over the limit 0 to infinity, sin t minus t cos t divided by t cube into dt. So subdivision 1 is also verified. We have proved. So next we have to prove the second subdivision using Parseval's identity. What is the Parseval's identity? Integral over the limit minus infinity to plus infinity, modulus f of x whole square dx is equal to integral over the limit minus infinity to plus infinity, modulus capital F of x whole square into ds. So always modulus function is even function. That's why you can write as 2 into integral over the limit 0 to infinity of modulus f of x whole square dx is equal to 2 into integral over the limit 0 to infinity modulus f of x whole square ds. So 2 cancel, left hand side, right hand side, same 2, so cancel. So integral over the limit 0 to infinity modulus f of x whole square dx is equal to integral over the limit 0 to infinity modulus f of x whole square ds. So therefore, f of x is a square minus x square. That is given in the problem. Capital F of s is, just now we have got 2 into root of 2 pi pi sin sa minus sa cos sa divided by s cube. Right? So you have to substitute these values. Integral over the limit 0 to a square minus x square whole square into dx, which is equal to integral over the limit 0 to infinity 2 into root of 2 pi pi sin sa minus sa cos sa divided by s cube whole square into ds. So a square minus x square whole square is equal to a minus b whole square, a square plus b square minus 2ab, a square minus x square whole square is equal to integral over the limit 0 to a power 4 plus x power 4 minus 2a square x square into dx, which is equal to 2 square 4 root of 2 pi pi whole square 2 pi pi. So 4 into 2 8 divided by pi integral over the limit 0 to infinity sin sa minus sa cos sa divided by s cube whole square ds. So a power 4x, you have to integrate a power 4 into dx. So a power 4x, x power 4 into dx plus x power 5 divided by 5 minus 2a square x square minus 2a square x square if you are differentiating x cube divided by 3, which is equal to 8 divided by 5 integral over the limit 0 to infinity sin sa minus sa cos sa divided by s cube whole square ds. So instead of x, you have to apply upper limit a, lower limit 0, a power 4x. If you apply a power 5 plus x power 5 divided by 5, a power 5 divided by 5 minus 2a square a cube divided by 3. So a square a cube will be a power 5 divided by 3, which is equal to 8 divided by 5 integral over the limit 0 to infinity sin sa minus sa cos sa divided by s cube whole square ds. By taking a is equal to 1, s is equal to t, d is equal to ds is equal to dt. So 1 plus 1 by 5 minus 2 by 3. If you are taking LCM, you will get 8 divided by 15, which is equal to 8 by pi integral over the limit 0 to infinity sin t, because a equal to 1, s equal to t. So sin t minus t cos t divided by t cube whole square into dt, because ds is equal to dt. So 8 divided by 15 into the right hand side is 8 divided by 5. If it comes to left hand side, it will be 5 divided by 8. So 8 divided by 5, 8 divided by 15 into 5 divided by 8, which is equal to integral over the limit 0 to infinity sin t minus t cos t divided by t cube whole square dt. So 8, 8 cancel. Answer is left hand side 5 divided by 15, which is equal to integral over the limit 0 to infinity sin t minus t cos t divided by t cube whole square into dt. So hence verified, hence proved second subdivision also. So thank you all.